Okay, so this will be on the advantage of factorials, because we're on chapter 5 regarding factorial design. And what's important to know is the factorial design, such as the two-factor factorial design, is more efficient than the one factor at a time factorial design. Why is that? Because it will help prevent cases where, when there is an interaction, that there's no error, there's no false conclusion, that cases where A minus B plus and A plus B minus give better responses than A minus B minus. Thus, it's important to have that discretion. The factorial design helps when you have the interaction, and it's a must. That's something that you need to remember. When there's an interaction, you have to use the factorial design. And specifically, let's look at the two-factor factorial design. This is the definition where there's A levels, factor A, and B levels of factor B. And it's important to know that there's going to be A times B treatment combinations. Okay. And this chart gives you a good example of raw data, and it's coded in the sense where you know what you need to use for this experiment. The material type is one factor, and temperature. Each of the factors has 3 levels. Now you can pause the video and give you some time to determine which of the factors levels belong to which, and if you're confident, feel free to list them, put them in the comments. Okay, hopefully that was enough time. So for material type, that's let's say factor A, and then 1 is level 1 of factor A, 2 is level 2 of factor A, 3 is level 3 of factor A. Temperature, 15 is, so temperature is factor B, 15 is level 1 of B, and then 70 is level 2 of B, and 125 is level 3 of B. We call this a 3 to 2 factorial design because there's 3 levels times 3 levels. And remember, this is based on the idea of the A times B treatment combinations. So one thing to note is when you have these 3 to 2 factorial designs, you may think all the factorial designs are squared, but A and B don't have to be the same. It could be 2 material types and 3 temperatures, or 3 material types and 2 temperatures. So it's not necessarily n to the 2 factorial design. So I'll keep that in mind moving forward. And the model is the effects model. It could also be the means model or the regression model. And the hypothesis involve either tau I, beta I, or the interaction between tau I and beta I. So this term here, tau I, beta I, can look very confusing, but tau I, beta I is involving blocks and also involving treatments. So hopefully that was helpful, and I'll go over the calculations here next.